Okay, so hopefully you're starting to get a little more comfortable with the representation of strings in C. Let me show you the kind of trouble we can run into if we forget this null terminator. So let me alternatively try to define this string, not as a const char, but just a char array with 5 elements. So I can define this as an array that has H, E, L, L, and O. Okay, and if I go to print this, what I'll see is the following. Okay, so it prints out hello, and then some garbage. Who knows what this is, right? That's because it doesn't have a null terminator, so it keeps going in memory until it reaches a 0 somewhere. And it prints out random stuff in between. Okay. Whatever happens to be in memory before it reaches a 0, assuming that it can keep going without reaching a seg fault, without reaching some invalid region of memory. So what I have to do is, if I'm going to do this manually, I need to make sure that I make the null terminator be my last character. So now this should work just fine. Okay. Now this is maybe a bit cumbersome way of defining strings. And another issue with it is it's difficult to do string concatenation. There are functions actually to do this implemented in C++, and you could certainly write your own. You just have to make a new array, right? So if I wanted to concatenate something to the end of this, I would just have to make a loop, copy over all the elements, all the characters in this first string, and then copy over all the elements in the second string after that. So it's just another one of those array tasks. But that's a lot of work to do just to concatenate 2 strings together. So C actually added a string object, and we'll talk about objects more next week, but we can at least use an object for now. So there's something called the standard library in C++ that comes with a bunch of very useful general purpose objects, and one of them is a string. So if I say include string, and I also have to say using namespace std, what this is saying is I'm going to use the standard library for a moment, so I can use some shorthand just to get straight to those methods that are in there. So this turns out to be a much easier way to deal with strings. So I can say, okay, so actually the string class is called string, actually with the lowercase s. Kind of annoying, not like Java, it's with the lowercase s. But then now I can say string s1 equals hello. And then I can say string s2 equals space world. And now I can say string s equals s1 plus s2. So now I'm back to doing things that were more like what I did in Java. Okay, now let's try to print this, just like I have been. And let's see, are we going to get hello world? Move this over a bit. No, we got nothing. What happened? So that's because this is an object. It's not actually an array of characters anymore. There's more stuff there around it. So one thing you can do is there's a method, there's an instance method in this object called called C_str. So what this will do is this will return a character array in the C style that represents the string in memory there. So that'll work. Just to really break it down and show you what's happening is, I'll call this cs equals s.cstring. So what it's doing is, and then it's saying you are not allowed to modify that once it's returned. Okay, so it's returning a const char pointer, so a pointer to an array in memory of the string that's been constructed here out of these two. And now I can treat that like a C array and print it with printf. Okay, so we've gone through a lot of trouble to print hello world, but there it is. But there's something that's a little more natural in C++ than doing it like this. You can actually print things using something called cout instead of printf. And then cout is a more object-oriented version, which can actually interpret something like a toString method in C++. So string's toString method would know to go to the array of characters in its memory and print them out. So let me use cout. Well, to use cout, I have to include another library, which is part of the standard library, called iostream. Okay, input-output stream. So here's the syntax for cout. It's going to look a little weird, but whenever you see this kind of thing, this is a C++ construct. Okay, so if I say cout left angle s, and then left angle /n, this is also going to do hello world. So there it is. So the way cout works is it actually, unlike printf, it takes one part of the thing you're going to be printing out at a time. And if you want to do more than that, so I wanted to do the string, but I also wanted to do the /n here, then you need to add another left arrow. Okay, so this is saying I want this to go out, and then I want this to go out after it. And I can keep going. I can say this is another line. So I don't actually care which one you use in your assignments. This is technically the C++ way of doing output, but it doesn't matter what you use. The only issue with cout right now in this class is that I've been having trouble getting it to work in the browser for the module. So in the browser, I'll always use printf, but you can feel free to use cout on any of the assignments or labs or class exercises. Okay. So that's all I really had to say about that. So that's the C++ way of dealing with strings. And there are a lot of things you can do with strings. They really have the functionality of Java strings when you declare them as objects instead of character pointers. Okay, so I'm just going to have you do a quick exercise with string concatenation, and then we'll move on to one more topic with pointers.